This is SAFE 2016 evaluation version. So, I have used this software to design my mat footing for the tall building. And you can see here there are 16 columns arranged in both X and Y, 6 meters apart, as you can see. Let us consider, I have made some assumptions. SBC equals to 300 kilonewton per meter square and allowable settlement of 1 centimeter, and I have got the subgrade modulus of 3 multiplied by 10 power of 4 kilonewton per meter cube, and the strips of 0.25 times of 18 meters, that is I have got 4.5, it is approximated as 4 meters. So before doing the designing of a footing, the first step is to define the materials. So I have defined a M40 concrete and a HYSD 500 for rebar materials, and then I defined slab properties, column properties, and I checked out load patterns, load cases for their linear static conditions, and load combinations for their service condition and ultimate strength condition. So after defining the required properties, and we need to now draw. I have selected grid sheet and I have drawn a slab with extensions of 2 meters on all sides of a building plan, as you can see here. This is because if we do not consider the extension, we will end with the corners of the columns. So to provide a relief to the extensions, I have considered an extension of 2 meters. So then the actual length and breadth of my mat foundation is resulted as a 22 meters. And after I have drawn columns and the slab and the strips, designed strips, as you can see, highlighting. This is not a strip. Yeah. Now I think you can. Now wait a minute. Yes, you can highlight in this. Yeah. Next, after drawing, we have to assign these properties. Okay. Uh, After assigning the soil properties and loads individually applied on each column, because of the size of load for punching shear changes, and the load also changes for every column because of the cross-sectional changes for the 4 columns in between these. These are the 600 by 600 and the extreme columns are the 500 by 500 columns. Then um you can see here the model has been locked because I have already run the analysis and the analysis design also have made it. Because of that, it has been locked. So after carrying out the analysis, the first step, the main important thing we have to check for its consideration is the show punching shear design. Here you can see here uh, the show punching shear design is less than 1 for every column, so my design is acceptable. If the design of the columns is greater than 1, then the columns is going to be failed out there. So we have to modify the slab thickness. So to change the slab thickness, we have to again unlock the model and change the slab thickness, and we have to carry out the analysis again. So you can see here, after checking that the design is considerable and we can go with this current slab properties in construction, let us check the extrusion view that we designed out. Okay, simply click it and go to the 3D view. You can see here this is an extruded view of my tall building design foundation. and go to the XY plane again. You can go to the extrusion tick off, and you will have this. If you go to show strip properties in the display, show strip forces, we can have the moment, the shear force in layer B. You can see here in both the layers simultaneously, and also you can go to show slab design and impose minimum reinforcing and apply. You can see here this is for the layer 1. It is indicating both top and bottom reinforcement intensity in different layers, and we can also check it out the show crack widths. If you apply here, these are the crack widths. The color code shows the crack width values in the range of 10 power minus 3, which is negligible. Yes, and after this you can go to the display and you can check the forces. This is moment 1, 2, and this is moment maximum I have got. This is force F1, 2, and this is Vmax, as you can see. Next, after this, we can go to run detailing, and you can see here in run detailing there are drawing component views, drawing sheets, and slab views. You can see here rebar table where there is a bar mark and respective diameters and shape codes, cutting lengths, numbers required, and you can see here this is a rebar schedule. This is a bill of quantity of the rebars 12 required and the length. And if you go to the individual slab views, these are the rebar plan, top rebar plan, and the bottom rebar plan, and the top rebar plan. This is a section 1. You can see here strip, design strip, that is. This is section 2, and these are the reinforcement profiles of layer and layer B. You can also have the list of drawings and general notes. Okay. Finally, my design for the mat footing for my tall building is successfully completed, and you can see here the extruded view and go to 3D. Now we can go to the detailed project report and we can print it out if it is a registered version, and we can directly go to the construction for our tall building foundation thing. Thank you very much. Thank you.